So that question wasn't so bad. So now we're on to question number 7. Draw the structural formula for the major product of the acid-base reaction shown below. So first I'm going to write down the reaction. Have an let's fix that. I'm so bad at writing hexagons. That looks weird, but so basically we have this molecule reacting with only 1 mole of HCl. So this is an acid-base reaction. So our base is this large molecule. Our acid is hydrochloric acid. And with acid and bases, the acid is the proton donor and the base is the proton acceptor. So basically we have 2 nitrogens on this molecule and each of them can act as a base, but since there's only 1 mole of HCl, we want to find out which one of these nitrogens will successfully take that proton. So which of these nitrogens is more basic? I'm just going to write that down. To quantify the basicity of an amine, we want to look at the pKa of its conjugate acid. So again, in order to find out which base is stronger, we want to look at the pKa of its conjugate acid. So I'm just going to draw out what these conjugate acids may look like. So in the case of pyridine, which I'll draw here, it will look like this. So that's the conjugate acid of pyridine. And for the primary amide, I'm just going to shorten this as R. If it were to accept the proton, it would kind of look like this. So another way you can call the pKa of a conjugate acid is to just call it the pKaH. And basically the trend for this is that the higher the pKaH, the stronger the base. So I know it's a bit confusing. So again, pKaH is the pKa of the conjugate acid of these bases, which I drew here. And basically, the higher the pKaH, you get a stronger base. So the stronger base will be able to deprotonate this 1 mole of HCl. So just to save us time, I looked up what the pKh of these bases were. For this one, it was around 5.2. For this one, it had a pKh of negative 0.5. So since the amine that is in the pyridine group has a higher pKh value, that makes it the stronger base. So therefore it's able to deprotonate the HCl. I can write our final product here. It'll have an positive charge. I'll just draw in the double bonds. Then this amine remains the same. And then, even though I don't have to include those ions, just write Cl minus there. Okay, so this is our final product. So it's the same. So this solution doesn't really look like it answers the question. Yeah, this looks like a different answer altogether. I'm just gonna write down the nitrogen in the ring will deprotonate HCl since it is a stronger base.